1.3 is about the product and quotient rule. Product, rule, quotient. So I'm just going to write these down for you first. Product rule. If you have two differentiable functions, so two functions you know how to take the derivative of, then you can take the derivative of their product, so you can do f times g, take the derivative by first taking the derivative of f and multiplying the result by g, and adding to that f times the derivative of g. So this is the product rule in one of its forms. It's written a whole bunch of ways. Sometimes you'll see x's in there. So you might see f of x times g of x prime. F of x times g of x prime is going to be equal to f prime of x times g of x plus f of x times g of x prime. Right, but the basic kind of formula for the product rule is if you have a product of two functions, to take the derivative, you have to do the derivative of the first times the regular second function with no derivative, plus the first regular first function with no derivative times the derivative of the second. So, let me write down the quotient rule for you. So the quotient rule says, again, if you have two differentiable functions, then if you have a division problem, f divided by g, or f over g, some function divided by another function, and you want to take the derivative, you do it by taking the derivative of the top times the regular bottom minus the regular top times the derivative of the bottom. So again, the prime switches, the derivative switches, but they're connected by a minus this time. And then you divide by the bottom square. So somebody, I don't know who, but some people, I don't know who it is. So if you have high over low, high is the top function, low is the bottom function, and you want to do the derivative. There we go. Low d high. You guys didn't catch that? Minus high d low. Take the derivative of the bottom second always. That's what's subtracted. Square the bottom, and away you go. Low d high minus high d low, square the bottom, and away you go. That's how students tell it to me sometimes. I don't remember it like that. I remember it like the top, because I'm math oriented. But if you like rhymes. So this is all we're doing today, pretty much. Just making sure we can use these rules. Okay? They will get massively complicated, but there's only two things really to remember. The one thing that I do, you cannot, it's not like a sum, okay? Products and quotients are not like sums. If you have the sum of two functions and you take the derivative, then it's the derivative of each. But if you have the product of two functions, you cannot just take the derivative of each and multiply. Let's do some examples. There's proof for both of these in your book, why these are true. I would do one of them, but I don't think it'll help you understand anything. I think you'll just get lost. So let's do a bunch of examples and see if that helps more. Find the derivative of each function. Start with a big. Y equals x squared plus 2 times x plus 3. Now, I could actually multiply, this is easy enough that I could multiply this out and do the derivative out. Right? But the point of the product rule is that you don't really want to multiply things out anymore, you just want to be able to attack this immediately without doing any algebra. So, the way the product rule works, I erased it, if you have f times g and you want to do the derivative, it's f prime g plus g prime f, or f g prime. So I have to have f times g before I do anything else. So I have to label my f and g. So in this case, because x squared plus 2 is being multiplied by x plus 3, this guy will be f of x, this guy will be g of x. So then I'll calculate f prime and g prime. What's f prime?
2x.
Plus?
Nothing.
Not that, right? Or 2, 0. And then what about the derivative of g?
1.
So then you can put it in the form. The derivative of the function y is equal to the derivative of this product, because y is f times g. And so to do the derivative of a product, first you write f prime, which is 2x. Then you write the original g function, which is x plus 3, plus the original f function times g prime. So be careful with the simplification in this section. On a test, if I want you to simplify, I will say simplify completely. Find the derivative and simplify completely. If I don't say that, you've taken the derivative right here. Okay. Of course, to match Larson in the back of the book, you're going to have to simplify everything. So this one's not too bad. Let's go ahead and see what happens. If you multiply this out, 2x squared plus 6x plus x squared plus 2. Collect like terms, 2x squared plus 1x squared, 3x squared, plus 6x plus 2. So there's your derivative.
I have a question.
I have an answer.
Now, I see what you're trying to do, like to actually use it as two functions.
Yes.
But I've just cross multiplied and I did it in 5 seconds.
Yes,
And
yes.
I waited, the answer is still the same.
Yes, so what's your question?
Why don't we just
We do.
okay.
Absolutely.
Alright.
Absolutely. Be careful of the instructions. You know, if I want to be a jerk, I might say use the product rule. And then you have to use the product rule. But if it just says take the derivative, whatever you want to do, whatever's faster for you, is fine. Okay. So I was going to go ahead and multiply this out as a check. All right, let's multiply it out and do the derivative and make sure we get the same thing. All right, the other method, the other approach here would be to multiply first. Right, do some algebra. If you FOIL this out, you'll get what?
X cubed plus 3x squared plus 2x plus 6.
So x cubed plus 3x squared plus 2x plus, sorry, 6. And then we can do y prime just with our power rule. So 3x squared plus 6x plus 2. Same thing. So if it's easier to do the algebra first, I would definitely recommend doing the algebra first because that'll probably save you time. But it won't always be easier. So for example, I could give you something like h of x equals x cubed minus x squared plus 2x times x to the 5th minus 3x plus 20. Now maybe you want to multiply this out, if you don't. Okay? But certainly I can keep adding terms here, right? I can give you a 10-term polynomial times another 10-term polynomial, and you're not going to want to multiply that out. So in this case, I would probably use the product rule, and certainly if it's 10 terms times 10 terms, I would definitely use the product rule. So what happens here with the product rule? What's my f and what's my g?
First term is your f.
First function, right? So this first function that's getting multiplied is your f. So f of x equals x cubed minus x squared plus 2x. And then the second function, second factor being multiplied, is your g. G of x equals x to the 5th minus 3x plus 20. Then you do the derivative of both of them. Right? In your formula, you're going to need to know f prime of x. What is it?
3x squared minus 2x plus 2.
3x squared minus 2x plus 2, right? Use your power rule. G prime,
5x to the 4th minus 3.
5x to the 4th minus 3. If you're a little bit more visual, another way you can remember the product rule is to set up your f and g, set up your f prime and your g prime right underneath, and then just multiply the diagonals and add the results. F times g prime plus f prime times g. We'll get you the same thing. So h prime of x is equal to, when I do f prime g, that's this product, f prime g. So I would do 3x squared minus 2x plus 2 times this guy. Plus fg prime is this diagonal. So f x cubed minus x squared plus 2x times g prime. At this point, I would definitely read the instructions very carefully and see if they ask you to simplify. If they don't waste your time. You're bound to mess something up.
That's it. F example.
Yeah, I know, right? We're only on B. Calm down, calm down. Once we get to like Z, it'll be 8. The important thing is you have to remember the formula, right? You have to know the formula. And well, that's about it. You have to know how to label your F and G, but that's pretty easy. Right now, the only way I can make this harder, I guess, would be to throw in maybe some trig functions. What happens if we throw in some trig functions?
What if it was F times G times H?
Yeah, we can do that. I'll do a 3. I'll do a 3 function. Let's do first though. Let's do h of t equals t cubed cos t. So again, you got to set up, this is, hopefully it's clear that this is a product, right? T cubed times cos t. So you got to set up your f function and your g function. F is clearly t cubed. G is hopefully clearly cos t. Do your derivatives. F prime of t is equal to 3t squared. G prime of t is equal to? Right, when you derive cosine, you get negative sign. So multiply and add. So let's see, when we do g times f prime, you'll get 3t squared cos t. Right, the derivative of the first times the second, plus the first times the derivative of the second. Which you probably want to clean up a little just because this negative is annoying you. You could even factor this. But certainly the negative times the positive will give you a negative. And then if you're feeling especially silly, you can factor a t squared out of both of these. Later on, when we start setting these equal to 0 and solving, you're going to have to do this. Okay, but for now, definitely more than welcome to stop here. So, we don't. I mean, you could do a triple product sometimes. Doesn't come all that often. But I could give you something like y equals x times x squared plus 7 times sine x. Ask you for the derivative. So there's a couple ways to do this. One is you can just actually multiply this out first. 2 is you could assign a product rule by picking this first thing to be f and the sign to be g, for example. The third is I could give you the triple product rule. Looks like this. If you have f times g times h, what's going to happen is the derivative goes to one of them each time. So it's f prime gh plus f g prime h plus f gh. how do you want to try to do it?
Rewrite everything, put it 1 in for the x.
Put a 1 in for x?
Yeah, the derivative of x, like the first term would be x squared plus 7 times sine x.
So if we assign this as our f, g, h, then the derivative would be, first you do the derivative of f, which is 1, times the other two. Plus, keep these two the same and derive this one.
X
So keep x the same, keep sine x the same. But then for the middle, you have to derive x squared plus 7, which is
2x.
And then finally, keep the other two the same and derive sine x. And the derivative of sine x is Sure. But I could give you, if I really wanted to, y sine x cos x, with an x out of front. You can't multiply anything.
You win.
So it's possible that I can make it so you cannot multiply things after you do it, but I'm not super interested in doing that. Yeah.
For number D,
Yeah.
is it also possible to just, instead of assigning it 3 f,
Yeah.
g, and h, just combine f and g together?
Sure, so
Be x cubed plus 7x times sine x? Do it that
yeah,
way?
that's what he was asking. He said another way to do this, and which would probably be faster, would be to write this as x cubed plus 7x times sine x. And then you just have f and g regular product. And that's when I brought up this example, where there's 3 functions here and you can't simplify anything at all. So sometimes it's possible that you would have to do something like this, but I'm quite happy if you can do this and apply the problem. Okay, let's do some quotient problems. So same thing, find the derivative. Now I'll give you a quote. So x minus 3 over x plus 2. So with f's and g's, the way the quotient rule works is if you have f divided by g, you want to do the derivative. Do the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. So in this case, my f is equal to what?
X minus 3.
F of x is x minus 3. G of x is
X plus 2.
x plus 2, right? G's the bottom, f's the top. The derivatives in both cases are what?
1.
1. Right? The derivative of x minus 3 is 1. The derivative of x plus 2. So in this case, you still have to multiply the diagonals, but when you multiply the derivative of the bottom, it's got to be subtracted. Like this guy, when you do the derivative of the bottom, that product has to be subtracted. Or you can just apply, look at the formula and apply it. h prime of x is going to equal f prime g, so f prime times g, which is x plus 2. Let me write the 1 in there so you see what I'm doing. F prime times g minus, because of the formula, or minus because of g prime f, so x minus 3 times 1, all over the bottom square. So we always have to divide by the bottom square. Divide by 2 squared. So the bottom was x plus 2, g was x plus 2, so we do x plus 2.
You put it 5 over.
Yeah, so this actually simplifies pretty nicely, so I would do the algebra here. Right, this negative gets distributed. The 1 doesn't do squat. Right, so this will become x plus 2 minus x plus 3 all over x plus 2 squared. Because 1x is positive and 1x is negative, they fight to the death. 5 over x plus 2 squared. Let me do one more basic quotient rule, and I'll try to trick you. One more to make sure you have the process down here. So y equals x squared plus 3x plus 7 over x cubed minus 13x.
Is that the F version?
Alright, so we have to do quotient rule because it's a quotient. So to take the derivative of a fraction or to take the derivative of a quotient, you have to do this rule. There's no other choice. God mandated it. So we assign an f of x and a g of x. F of x is always the top. G of x is the bottom. And you do your derivatives.
2x plus 3.
F prime, 2x, right, because the 2 comes down. 3, right, because the derivative of x is 1. For g prime,
3x squared minus 13.
the 3 comes down. Exponent drops to a 2, minus 13. G, so these have to get multiplied, these have to get multiplied, and you subtract. You divide everything by g squared. So y prime is equal to 2x plus 3 times x cubed minus 13x minus, right, the formula got a minus, square plus 3x plus 7 times this next guy, 3x squared minus 13. All over
X squared minus
the bottom square, x cubed minus 13x.
What is the confusion? What is the confusion? Said I'll confuse you.
No, not yet. I said one more regular one, then I'll confuse you.
Oh, okay.
So I wanted to get the process down. So this is pretty standard, right? You just assign the top, assign the bottom, do your derivatives, do your formula.
This one will be F times G divided by.
Ooh, do you need to do one of those, but not yet. Let's see what I got. Store for So sometimes this tricks people. It shouldn't, but it might. Suppose I gave you x, my function, h of x, and I gave you x squared minus 3 over 5.
Not good.
And again, I want you to take the derivative.
But isn't that 1 over 5 time x
Yes, so you could do the quotient rule on this and it would give you the right derivative, but you would be wasting your time a little bit. Okay, because this division by 5 you can rewrite as multiplication by 1/5. And then you have a constant multiple out front. When you do the derivative with a constant multiple out front, you just do the derivative of the x part and then multiply by the constant. So h prime here will be 1/5 times, then do the derivative of the inside here. Just 2x. 3 goes to 0. So altogether, h prime of x is 2x over 5. You can do it with the quotient rule. I'll do it quickly to show you. But if the bottom is a constant, there's no need. Right? You can rewrite the constant as a multiple out front. However, if that's blowing your mind, you could do it exactly the same way and we should get the same answer. I hope, or else calculus is broken. I'm going to go home and shoot myself. So, if I didn't recognize this and use the quotient rule, the top would be f, which is x squared minus 3. The bottom would just be 5. The derivative of f, the derivative of the top, 2x. The derivative of the bottom, 0, right? That's what you need to get here. G prime of x, the derivative of a constant is 0. Up, subtract down, divide by g squared. So h prime of x is equal to 2x times 5 minus 0 over g squared, 5 squared. So then we can probably simplify this. 10x over 25, or if you reduce, the 5 goes in the top and bottom, 2x over 4. So you get to the same place, but you just waste a lot of time. So I know you guys are all about doing it the fastest way possible. I'm getting that. So none of you will do this. All of you will do this if it's a constant on the bottom. All right? That's it. Now, if it's a constant on top, that's different. And if I switch this around, y equal to 5 over x squared minus 3. Right now, at this point in time, we will learn a slightly easier way to do this later. But at this point in time, we really have no choice. We have to do quotient. Because even if you factor out the 5, we still have 1 over x squared minus 3, which we don't know how to derive. We don't have a rule for that. So if the constant is on top, you really have to do the quotient. Set f of x equal to 5, g of x equal to x squared minus 3. F prime, derivative of a constant, 0. G prime, 2x, and do your multiplication. Alright, so y prime in this case would equal, this first multiplication is useless, right? 0 times anything is still going to be 0. Minus 5 times 2x will be 10x. I'll just write 5 times 2x. Over bottom square. So negative 10x over x squared minus 3. Okay, so constant on bottom, you can pull it out as a fraction. Constant on top, you gotta do it. Gotta do the quotient.
When do you want us to stop simplifying?
This guy doesn't simplify.
I mean, as far as the bottom?
Expanding is not simplifying. I wouldn't expand things out unless... The only reason you expand on the top sometimes, or sometimes you expand in order to collect like terms, but if you expand this, there's not going to be any like terms to collect because there's nothing else over here. In general, though, if it does not say simplify your answer completely, once you do you could leave it here, and I'd think you were a little off, but I'd give you some credit. I'd be like, oh, this guy doesn't know what 5 times 2 is. That's a shame. But 3 points. If it says simplify completely, then I want you to multiply out all the numerators and collect like terms and then try to cancel. If I ask that, I'm going to be disappointed. So I probably won't ask. At some point, it will become necessary, and then I'll do a bunch of problems to help you used to it. But for now, let's get these rules down. Get the calculus. So, another one that sometimes tricks people. You guys don't like exponents on your signs, I know that. So sine squared x, if I want to do the derivative, how can we do this? You've got to break it down into sine times sine. Do not try anything shady where you take the derivative of sine and it's cosine and then you square it or something ridiculous, okay? It's not. You have to do sine times sine. And then it's a product rule. You have an f and a g. F of x equals sine x. G of x also equals sine x. Do your derivatives, f prime, derivative of sine? Cosine. G prime, same thing. Multiply. And add in this case, right? Because you're doing the product rule. Y prime would equal, so you do cosine times sine, cos x times sine x, plus sine times cosine. Yeah, but these are the same thing. So you can add these together. Y prime equals 2 sine x cos x. And if you're super trig student, which I know you all are, you'll recognize this as a formula from trig. we'll stop here. We could go to here. So at this point in the game, when you have a function squared, you're going to need to write it out as a product, and then do a product. You don't really know any other way to do it.
Why are we adding it?
Here, that's the product rule.
Oh, we're doing.
Yeah, because it's a square, it turns into a product. Yeah, if it were, yeah, it's not division. All right. Let's see, let's do h of x equals x sine x divided by x plus y. So this is going to be a combination, right? Because I have a product on top, and then I also have a quotient on the other. So what do you think we can do?
We'll start with the top first. Get it the derivative.
Product first.
Yeah, I mean, so, okay, I guess there's a couple of ways to do this, but
X over x plus 5, sine x over x plus 5.
no, if it were plus, you could do the x plus 5 into both of them. If it's multiplication, the way to rewrite this, if you wanted to rewrite it, would be like x over x plus 5 times sine x,
Oh,
because it's multiplication. But I would probably jump straight in with the quotient rule. Or if I want to do the derivative, you kind of start with the outermost operation. Do you know what I mean by outermost operation?
No.
So if I plugged in 1 here, 1, 1, 1, what would you do first to evaluate it? Well, let's do 2, or pi over 2 or something. 2. What's the first operation you would do? 2 times sine, well, you find sine 2 on your calculator, and then after that you would do multiplication. Then you would have to figure out what 2 plus 5 is, and then finally you would divide them. So when you do the derivative, you want to kind of go in the reverse order. Right? The outermost operation, the last thing you do is division. So I'm going to start with the quotient rule. Inside the quotient rule, right, inside of this quotient, I have extra stuff to do. I have a product to do. But the way you're going to break this down is to start labeling an f and a g based on the quotient. So f of x will be the top, g of x will be the bottom. The problem is now when you calculate f prime, you see what you have to do?
Yep.
When you calculate f prime, you have a product rule. Because it's got a product, f has a product. G prime is easy, I'll do g prime. G prime is just 1. But to fill in this part of our quotient rule, we need to do product. Can you do it without, can you do it? Just in your head right here, maybe?
Negative cosine x.
So you do the derivative of the first times the second. So the derivative of the first is 1 times the second is sine x plus the first times the derivative of the second. So x cos x.
Just it's.
Sorry, I have to erase this. So you guys see how I did that derivative? I didn't write it down. Mainly because I have an f already. But you have to do the derivative of the first, which is 1, and then you keep the second. So this guy was a derivative. the second stayed the same. And then when you move on to the next one, you leave the first one the same, the x stayed the same, but then you do the derivative of the second. Derivative of sine. So inside of the quotient rule, there was a product rule, which we did. And then we have to finish off the quotient rule, which says multiply these guys and multiply these guys and subtract. Divided by these. The derivative of h will have this monstrosity multiplied by x plus 5. Right, so you'll have sine x plus x cos x times x plus 5. Minus this guy times this guy, since g prime is 1, it'll just be x sine x over g squared. Now, if you were trying to simplify this guy, you would have to multiply out here, because something here could collect with this. And in fact, something here will collect with this, right? Because you'll have an x times sine x. Which will go away with this. You guys think you could simplify this? Of course. I like that confidence.
Fake.
If I asked you to simplify, say, what would you do?
X sine x.
So you actually have to multiply this
sine
out.
x.
Sine x times sine x times 5, x cos x times x cos x times 5. So sine x times x, you can't do anything except write them right next to each other. Do not multiply the x inside of the sine times the x outside of the sine. The x inside of the sine is trapped. Okay, he's in prison, he cannot communicate with this guy. So you just get x sine x plus 5 sine x.
X squared cosine x.
Now this guy, because this x is out front, when you multiply x cos x times x, it's x squared. Then cos x
5 cosine
plus 5x cos x
minus x sine.
minus this original guy
Which goes away.
over the bottom square. That problem doesn't like you. So these fight to the death. I have no idea how the problem feels.
Couldn't one of the x plus 5s cancel?
How? No. In order for an x plus 5 to cancel, you'd have to have an x plus 5 factor. Like x plus 5 in parentheses.
Can't you put cosine x parentheses x squared plus 5x?
Sure, but it's still not factor because this guy's being added here.
Yeah.
If it were just this,
Yeah.
then you'd be good. Then you could factor and cancel some things. But because of this guy, we're okay, so I have to get to the other trig functions. So I'll do another one of these maybe on Wednesday, where there's a product rule inside of a quotient rule or something like that. But let me talk about tangent for a second. we now know enough to do the derivative of tangent. Right, before we just had sine and cosine. Right, but now we can take the derivative of tangent by rewriting it as a quotient, as a fraction. I can rewrite this as sine x over cos x, and then I can apply the quotient rule to get the derivative. So if I want to find the derivative of tangent, I rewrite it as sine over cosine, and then I do my quotient. F is the top, G is the bottom. F of x equals sine x. G of x equals cos x. Derivative of sine, regular cos. Derivative of cosine, negative sine. Get it? It's got a negative sign. Then you multiply, up, down, subtract, divide by g squared. So y prime is equal to cos times cos, which is cos squared, minus sine times negative sine, which is negative sine squared, over cosine squared. And this you absolutely want to simplify.
1 minus sine.
Yeah, we have cosine squared plus sine squared. So cosine squared plus sine squared we know is 1. I hope. We knew at some point. Somebody in your life told you that, I'm betting. Maybe it was just parents. Facts of life. So the top becomes 1, the bottom is cos squared. 1 over cosine is equal to secant. So altogether we have y prime is equal to secant. Okay?
Bueno.
Bueno. I'm just keeping my language. L. What else can we do? Not tangent, let's do secant. Yeah, buddy. Super excited about that secant.
Why don't we simplify it to 1 over cosine?
Yeah, absolutely. We're gonna change this to 1 over cos x. But remember, when there's a constant in top, it's not any easier. We have to do quotient rule still. So we have a quotient. We can apply quotient rule.
0 minus cosine.
So we'll do f of x, the top function, equal to 1. G of x, the bottom function, equal to cos x. Derivative of 1 is 0. Derivative of constant, 0. Derivative of cosine, negative sine. Multiply up, multiply down, subtract. Divide by g squared. So y prime in this case will equal, let's see, 0 times cos x, so that's 0, minus 1 times negative sine x, so minus negative sine x, all over cos squared, all over the bottom square. Again, this simplifies. First of all, negative, negative. This is positive sine x on top, cos squared on the bottom.
Sine x secant squared x.
So sine x secant squared x. Yeah, I've never heard that. I've been doing derivatives and secant for 10, 15 years. I've never heard that. All right, so this is sine x over cos x times 1 over cos x. Usually this is the way it's broken out. Nothing wrong with what you did, but this is usually.
So tangent
Tangent secant. The derivative of secant is secant tan. Day, come up with y prime equals tan x times or secant x times tan. Usually that's the way it's written in books. Secant tan. Any of these are equivalent.
It's definitely sine secant squared.
Sine secant squared. I don't know why not. I don't know.
That is like
So we actually can do the same thing with cosecant and cotangent. All right, it's not super difficult. But let me just kind of list out your derivatives now. You have to know the derivatives of your 6 trig functions. And they are as follows. And this order might make it a little bit easier to memorize. I don't know, but if you have sine, let's do sine, tangent, and secant. And then we'll do cosine, cotangent, and cosine. So when you do the derivative of sine equal to cosine, when you do the derivative of tangent, we just did that one. Remember what we got? Secant squared. When you do the derivative of secant, oh, it's still written. Secant tangent. Right, so the derivative of secant is secant again, but it also picks up a tangent. Now the other 3 follow the same pattern but have negative signs. So the derivative of cos x is negative sine x, right? We saw that already. The derivative of cotangent x is going to be negative, instead of secant, cosecant squared x. And then the derivative of cosecant, right? It's going to be negative, right? All of these pick up negatives, all the co-functions, cosine, cotangent, cosecant, they all pick up negatives. But it's going to be negative cosecant x, cotangent x. So let me do one more example. If you don't remember these, then you have to do the quotient rule on all of them, okay? Hopefully you'll memorize them though, because they're not. It's better that you know these very quickly. One last thing. Find the first and second derivative of the function y equals secant x. So what do you think second derivative means?
The derivative of the
The
derivative.
derivative of the derivative. Derivative of the derivative.
Do we give it to whatever?
Yeah, and the notation for second derivative is 2 primes. Third derivative would be the derivative of the derivative of the derivative, and you give it 3 primes. Okay, so you can do as many derivatives as you want. Just keep taking the derivative. In this particular case, y prime is easy because we just wrote it down. What's the derivative of secant? Secant tangent. Okay. Yeah, but now when we move on and we do the second derivative, which we'll notate with y double prime, we have a product rule. I want you to write a product rule. Right, to do the derivative of the derivative, or the second derivative, I have to label an f and a g, and then do my product rule. F of x is secant, g of x is tan. Derivative of secant is what?
Secant tangent.
Secant tangent, again. That's what we've just done 3 times now. Derivative of tangent, secant squared. It's written right over there. So then you have to do multiply up, multiply down, subtract. Oh no, add. Product. Product, so we add.
Oh, this is awesome. Cute.
So y double prime, right, the second derivative altogether, will have a secant tan times a tangent plus a secant x times a secant x squared.
Which we can factor with secant.
Yeah, we can simplify this a little bit.
Secant tangent square, secant square.
Yeah, certainly I would multiply these tangents and get a tangent squared. Secant x tangent squared x plus secant times secant squared is secant cubed x. I'll leave it at that. If you want, you can factor out a secant.
There is nothing that says tangent square plus secant square equal anything, right?
Well, secant squared minus tangent squared is 1. But
But this is gonna stay as
tangent squared plus secant squared is not. Alright, that's all I got.